In this video, we'll be solving a question from quadratic equation. The equation x square plus b square equal to 1 minus 2bx and x square plus a square equal to 1 minus 2ax have one and only one root in common. These two quadratic equation has a single root in common. Then which of the following is incorrect? We need to figure it out which one is incorrect. First of all, I'll be writing this quadratic equation. I'll be bringing every term from the RHS side to the LHS side. So it will become x square plus 2bx plus b square minus 1. Similarly, the other equation, only the variable will be changing. It will be 2ax plus a square minus 1 equal to 0. Now we have two quadratic equation, right? Now the thing is, in the question it is clearly said that they have only one and only root, which means if the quadratic equations are same, that is, if the quadratic equation will be same when a equal to b, in that case whatever the root a the first quadratic equation has, that too will be the same root for the second equation. That means since they have only single root in common, a shouldn't be equal to b, which means a minus b not equal to 0 or b minus a not equal to 0. They shouldn't be equal value. That's the thing. This condition is correct. That is a minus b not equal to 0 is correct. Now how will you solve this question? Now remember one thing. Suppose this first polynomial I am calling as p of x and another polynomial I am calling as g of x. Suppose these two polynomial has alpha and beta. Alpha is the root of these two polynomial, right? Now what is the root of p of x plus g of x? That is, the thing is, suppose p of alpha is a root of p of x, means p of alpha will be 0. And similarly, g of alpha, since alpha is a root of g of x, also g of alpha will be equal to 0. Now, p of alpha plus g of alpha will be equal to 0. That means when you take sum or when you take difference, the thing is, the root of this polynomial, if you have given if you are given with the two polynomial, then when you add two polynomial, you will get a resultant polynomial as a sum, or sometimes you will subtract, you will get the resultant polynomial as the difference. The root of that polynomial can be means it can or cannot be, can be the root of the original polynomial. So if they have same root, means it's definitely one of the root of this combined polynomial will be the equal root of these two polynomial. That's the logic. That means suppose p of x I am writing as x square and g of x I am writing as x. What is p of x plus g of x? P of x plus g of x is actually x square plus x, right? Now, if you factorize this one, this polynomial x and x into x plus 1. Now, 0 is root of this polynomial and similarly minus 1 is root of this polynomial. The thing is, 0 is already root of these two polynomial. So, root of this polynomial will be root of the sum. That's one logic. If they have a common root, and this can or cannot be the root. That's the thing. If there are two values, that the second value can or cannot be the root value. The thing is, suppose you are given with a polynomial p of x and g of x. When you add, if they have alpha and beta are the roots, if they have alpha and root of the beta are the roots of the equation, this alpha can be the root of p of x and alpha can be root of g of x. Similarly, beta can be the root of g of p of x and beta can be the root of g of x. Why I am telling it is can be means, suppose you are given with a g of x function as x plus 1 and p of x as x minus 1. Now what is p of x plus g of x? P of x plus g of x is actually, this will be 2x. So root of p of x and g of x is 0. Root of g of x is minus 1 and root of p of x is plus 1. This is the root of p of x and g of x, which means if g of x and p of x have a root, it will be a root of p of x plus g of x or p of x minus g of x. If p of x plus g of x have a root, then it can or cannot be the root of g of x and p of x. That's the thing. Here it is, here the root of p of x plus g of x is 0, which is not a root of both. But here, in this case, they have two root common and one of the root is common. That's the root. It can or cannot be. That's the logic. Now we will be following the same thing. We have given two polynomial, that is x square plus 2bx plus b square minus 1, and another polynomial will be x square plus 2ax plus a square minus 1. Now in this question we will be using the logic p of x plus g of x, right? Now we will be adding. When you add, you will get p of x plus g of x, which is equal to 2x square plus 2 into a plus b of x plus a square plus b square minus 2 equal to 0. Now, since p of x and g of x has one common root, that is alpha. If it is alpha, let it be. Then alpha will be the root of this thing, right? That is alpha. Alpha will also satisfy this thing, because alpha, if alpha is the root of p of x and alpha is the root of g of x, it will be 100% root of p of x plus g of x, because p of alpha plus g of alpha will be 0 plus 0, it will be 0. That means that's the one condition. Now, suppose that means alpha is confirmed. That's the common root of p of x and g of x. Now, if this has one more value, that is beta as the root of p of x plus g of x, then it can or cannot be the root of p of x and g of x, which means it can. This beta can, if beta is the root of p of alpha plus g of alpha, means it's not necessary it will be the common root of p of x and g of x. That's what we did with the example. Now the thing is, we are stating that this particular expression has only one root as the answer, which means this quadratication has equal root, and that root is only single value, that is alpha exists. Now it's 100% sure that this will be one of the root or common root of this and this. That's why we will be claiming that this particular quadratication has only a single root which are equal in magnitude. That means equal root and real root. That alpha will be the root of this one. Now it's 100%. Already question is telling one of the root is alpha, which is the root, common root, and it will be a root of this one. Now we are telling only one single value exists, because we are eliminating that condition. The another root can be there, present there or not. That's why we will be equating this b square minus 4ac, that is discriminant of this quadratic equation, with 0. That means b square minus 4ac will be equal to 0. Now what is the value of b square? B is actually 2a, so it will be 4 into a plus b the whole square. B square minus 4 into a value is 2 and c value is a square plus b square minus 2. So it will be a square plus b square minus 2 equal to 0. Now we can cancel this 4 from here. Now a square plus b square will be equal to a square plus 2ab plus b square minus 2a square minus 2b square minus of minus plus 4 equal to 0. We just distributed this value. Now here this will be cancelling and it will become minus a square. Similarly, this will become minus b square, and this will become plus 2ab, and it will become 4, which is equal to 0. We will be multiplying this equation throughout with a negative sign. So this will become negative minus 4 equal to 0. This can be written as a plus b, a minus b the whole square, or b minus a the whole square, minus 4 equal to 0. That is a minus b the whole square equal to 4. Now we will be writing a minus b can be equal to plus or minus 2. Case 1, a minus b equal to 2. Case 2, a minus b equal to minus 2. Now a minus b equal to 2 is correct, and a minus b plus 2 is correct, because in our option they have asked a minus b plus 2. So these two values are correct. So our final answer is a minus b not equal to 3 is our correct answer. And sometimes this question is asked, they will only ask the magnitude of a minus b. In that case, a minus b is plus or minus 2. So modulus of plus or minus 2 will be equal to 2 only. Now if you want, we can solve this question in one more method. That is, suppose alpha is the root of p of x and g of x. That is, both the polynomial has common root alpha. Then p of alpha minus g of alpha will be also 0. That means, suppose we are defining a function f of x equal to p of x minus g of x. Now, f of alpha equal to 0 means p of alpha minus g of alpha, which is equal to 0, means alpha is the root of this combination. That is the root of this individual polynomial. That's how we'll be solving it. In that case, we can find the common root. For finding the common root, I am telling, let alpha be the root of these two polynomials. First, we can write this polynomial x square plus 2bx plus b square minus 1 equal to 0. Another one is x square plus 2ax plus a square minus 1 equal to 0. Now, we need to find the common root alpha. For that, we will be subtracting these two equations. So, when you subtract, x square will be cancelled. and 2bx minus 2ax. Here b square minus a square will be there, and minus 1 and plus 1 will be cancelled. Now here you can take a 2x common, it will be b minus a. Here you can write a square minus b square entity, that is a minus b into a plus b, which is equal to 0. Now you can take b minus a common, then it will be 2x plus a plus b equal to 0. Now the thing is, we already know a minus b not equal to 0. If a minus b equal to 0 means a and b will be same, both the polynomial will be same, they have two roots in common. Therefore, this is a non-zero number. When you divide 0 divided by non-zero number, the value will be 0. That's how you can bring this there and you can divide it. Now here, this can or cannot be equal to 0 because it's a variable. Therefore, we can find the root 2x equal to minus of a plus b, which means x equal to minus of a plus b divided by 2. Now we can, this is the root, this is the common root alpha. This is the root of this p of x minus g of x. P of x minus g of x, the common root of this one. That will be the root of these two polynomial. You can pick any of the polynomial. Either you can take x square plus a square or x square plus b square. I am taking x square plus b square. So it is x square plus b square equal to 1 minus 2bx. Or you can take this expression also, both will give the same thing. We will just simplify. Now, since this is the root of p of alpha minus p of x and g of x, p of x minus g of x, that will be the common root of this polynomial also, because that we have only got one root, that's the common root. Whenever you take difference, you will get one root only. If you are adding, that means earlier we added, that time we only consider the example of having a single root, two root equal. Here, when we subtracted, we got a linear equation. It has only one root. That's the difference. There you need to think about existence of only equal and real root. Here you don't need to think anything. Whatever the value you are getting, that is applicable for both the quadratic equation. Now here, when you apply this value, this will become minus of a plus b divided by 2 the whole square plus a b square equal to 1 minus 2b into a plus b divided by 2, and this minus will be cancelled because x is already having this negative. So here already there was a negative that I took common and cancel with this negative. Now you will be simplifying this value. This will be a plus b the whole square. Numerator will be a plus b the whole square, that is a square plus b square plus 2ab divided by 4 plus a b square equal to 1 plus can cancel this 2 over here. This 2 will be cancelled, 2 will be cancelled. It will be ab plus a b square. You can cancel this b square. Here, when you cross multiply this 4, a square plus b square plus 2ab equal to 4 plus 4ab. Now, when you bring this over here, a square plus b square minus 2ab equal to 4, which means a minus b the whole square equal to 4. That is a minus b equal to plus or minus 2, which means a minus b equal to 2 or a minus b equal to minus 2, that is a minus b again equal to 2, same thing. This is a minus b plus 2 equal to 0. So first two conditions are correct. You can do with the difference also. When you take difference, you will get only single value, that is the common root. When you add, then you should consider about having a single root only, then only you will get the solution.